Hey everyone, today we will solve this problem, longest palindromic subsequence. So basically you are given a string and you have to find the length of the longest palindromic subsequence. Let's understand the problem first. So what is a palindrome? So palindrome is a string which is same from both left and right, or in other words a string which is reverse of itself. For example, here BABC, BAB is a palindrome because if you read it from left to right or if you read it from right to left, both are same. Or we can say like if you reverse this string, then it becomes the same string. Okay, second thing is what is the subsequence? So we defined it in the last video as well. It is part of a given string that can be obtained by removing 0 or more characters. That is, if you are given this string, then I am removing a few characters and I can obtain this string. Let's take another example. Like you are given this string ACXWS. Then if I choose these characters A, W and S, so AWS will become a subsequence. The original string ACXWS is also a subsequence. Like we have to remove 0 or more characters. So here I am removing 0 characters. So there are two properties of subsequence that we can see. So first thing is it is made up of the characters present in the original string, and second is the order of characters is same as provided in the original string. You can build this AWS, but you cannot build the ASW. You cannot change the order of the characters. Cool. So now we know what a subsequence is and what a palindrome is. So how can we find out the longest palindromic subsequence for a given string? Let's see. So if a subsequence is a palindrome, it means it is a subsequence of the reverse of original string as well. What I mean is, so this is our string and we know that BABC BAB is a subsequence for this string. And since we also know that it is a palindrome, that means if we go in this direction, then we can find this subsequence. And since it is a palindrome, like if we go in this direction, also we can find this subsequence. So doesn't it mean that it is a common subsequence of the given string and the reverse of its string? If I write the reverse of string like this, BACB, CBABB, so this is a reverse of the string, then this subsequence, which could be found from right to left, now in reverse string we can find it from left to right. So we can say that this is our original string and this is our reverse string, and in both of these strings this subsequence can be found from left to right. So this problem is now simply converted into the standard longest common subsequence problem. That is, you have to find the longest common subsequence of a string and its reverse. Although LCS is very standard problem, but still I will try to explain it here, how we approach the LCS problem or longest common subsequence problem. Suppose we are given two strings S1 and S2. S1 is of length m and S2 is of length n, and we want to find the longest subsequence which is present in both of these strings. So there is a simple substructure we can see, that is, if we pick the last character of these two strings, let's suppose this is something like 0, 1, 2, something like m minus 1, and here is something like 0, 1, 2 up to n minus 1. Now if we pick these last two characters, then there are two cases, that is, either these two characters are same or these two characters are different. So let's say case 1, these two characters are different. That means they cannot be present together in the longest common subsequence. Let's prove. In contradiction, let's take both of them in our common subsequence. Let's say this character comes later than this character in the common subsequence that we have. Let's suppose this is X and this is Y, the last character. Now if we take these two characters in our common subsequence, so one of these characters would be the end of the string, right? So let's say X comes before Y and Y makes the end of the string. Now since this is the common subsequence, that is, it is in both of these strings, so Y should also be matching to some character which is present after X, but X is the last character, right? So that means both of these characters cannot come together. So that was a mathematical way, but you can also see it intuitively. You can just see both of these characters x and y are the last characters. So if they are present in a subsequence, then they have to be the last character. And since these two characters are different, so they cannot be the last character of the same subsequence. So that means, like, if these two characters are different, they cannot be part of the common subsequence. So either we have to remove x or we have to remove y. That means either we have to use s1 of length m-1, that is prefix of s1, and use the s2 and find the longest common subsequence from this, or we have to remove this y. So we will use s1 and we will use the prefix of s2 of length n-1, like removing this y character. So we will find LCS for this case and we will find LCS of this case, and whatever is greater we will use that. So it is maximum of these two. So that is the case 1, when both of these characters are different. Now case 2, that both of these characters are same. When both of these characters are same, it is better to use this character in our LCS. That means we use this x in the end and whatever remaining is, and we can find LCS of this remaining string and this remaining string. So it will be whatever the LCS of this s1 minus 1 and s2 minus 1, and then x is appended. So that will be our longest subsequence for s1 and s2. So its length will be LCS of this s1 minus 1 and s2 minus 1 plus 1, because x is of length 1, right? So these are the two cases. So now I will only show the bottom approach here. At any point we are given two strings, right, s1 and s2, and which are actually the prefixes of the original string. Like if we are using s1 minus 1, so that will be like using 0 to m minus 1 character, m minus 2 characters. If we are using of length 2, then we are using 0 and 1 character, right? So it will always be the prefix of the original string, and similar case for s2. So at any point if we want to define a string, we can just use the length of the prefix that we are choosing. So LCS of s1 comma s2 consists of two states, that is length of the first prefix and length of the second prefix. So we can use a 2D DP here because there are two states. So let's define this something like LCS of length 1 and length 2. So length 1 is like the prefix length of string 1, and length L2 is the prefix length of string 2. So if the last characters are same, we can say it is 1 plus LCS of L1 minus 1 and L2 minus 1, like the last character is being used. And otherwise it will be the maximum of LCS of L1 minus 1 comma L2 and LCS of L1 comma L2 minus 1, like one of the last characters is removed. So basically it will be a grid where this will be your L1 and here it will be, let's say, L2. So let's say this so this will be your LCS of L1 comma L2, and it will require three numbers: LCS of L1 minus 1, L2 minus 1, which will be here, or like this will be your L minus 1, right? This will be your L1, this will be your L1 minus 1. Similarly, this will be your L2, and so this will be your L2 minus 1. So L1 minus 1, L2 minus 1 will be here. Another one will be LCS of L1 minus 1 comma L2, which will be here. And last one, LCS of L1 comma L2 minus 1, this will be here. So this number will be dependent on these three numbers. So we have to fill these three numbers before filling this, right? So either way we can fill it like this. Then also, like when we are at this number, we will already have the values of these three. Or second way will be, we can fill it like this. So when we are at this number, we will again have these three numbers, the value of these three numbers, right? So any way you prefer, we can fill that. One more thing, when you are filling of these extreme points like this or this, so you do not have the on top of this, and similarly you do not have the number on left of this. So these are the base cases. So basically first you have to fill this column and this row, and in the loop you can fill the remaining grid. Okay, let's code it. So first n equals a dot length, let's say, and we have to find the LCS of this given string and the reverse string. So s1 will be our given string, and now reverse. So S2 will be a reverse string. And define TP. These are the length. So length can vary from 0 up to n. So there are total n plus 1 numbers, right? Comes the base case. Base case will be the extreme positions, like either left or top. So this will be your when column is 0. And this will be your when your row is 0. And then let's loop. So when the last characters are same, then it will be 1 plus TP of I minus 1 j minus 1. Otherwise it will be the maximum. Either we removing it from the first string or we removing the last character of the second string. And finally we are returning the answer when the first string is of length n and the second string is also of length n. That should be it. Okay, we have to change J. So yeah, it worked fine. Let's submit it. And see, that's how it works. So that's how we use bottom-up approach to solve this LCS problem. Hope it helped you somewhere in how to think intuitively, how to approach a problem, etc. Please let me know in the comment section if it helped you anyhow. Without that, I would not understand if I'm even helping anyone. Also, feel free to ask me any questions or any doubts in the comment section. I'll be happy to answer. Thanks a lot. If you're still watching, have a great day ahead. Bye bye.